Senior Solutions Architect in Technology Services Group at SoftServe. His role is better described as a chief alchemist. His current activities at SoftServe include leading an IoT team, designing and implementing a complex IoT system, and public-private cloud solutions. He'll be joined by Serhiy, who is the head of Technology Services Group at SoftServe. This is a technology consultancy team with unique skills in big data, data science, DevOps, security, and IoT. Serhiy and his team are active adopters and contributors to SEI architectural methods. So, good luck.
Thank you. It's our pleasure to see all of you in this beautiful location at SATURN conference. And this is really great to see how many people are interested in IoT. Before starting the presentation, let me apologize for changing our topic from reference architectures to reference architecture, from plural to singular. The reason is that it's a really challenge to describe multiple architectures in just such a short time frame. So we'll do our best to show you the most popular or the most generic reference architecture, if you will, show a case study, and a fun demo at the end of our session. So let me start this presentation with a quote of a famous physicist and philosopher Albert Einstein. Look deep into nature, and then you will understand everything better. And in fact, if we look at the modern IoT system, we can see that it resembles human. It resembles a crown of creation, if you like. So it can sense as we sense. It can collect tons of data from real world using sensors and Statoil and GE shown the whole variety of possible sensors. They could be temperature, video, audio, machine-generated data, and so on and so on. The data is learned by the modern IoT system using machine learning algorithms, using artificial intelligence algorithms. And if the system cannot solve a complex decision-making problem right now, it just outsources to human colleagues. But that's a temporary solution, probably. So the system can act using generated rules from learning experience, or just translate the operator commands to actuators. And the system can operate including in a certain environment, actually, including hardware and including software. And unlike us, humans, fortunately or unfortunately, the system can be upgraded to a newer version. So when we map this cognitive loop abstraction to a more physical representation, we may notice that cloud is on a top central location. So why cloud, and why is that? One of the major reasons is that we need to implement conscious and cogitative functions. And these functions are very resource consuming. So just to give you an example, in image recognition, it takes several hours to train a relatively simple network to distinguish a frog from a car, for example. And sometimes there is a need of real-time communication between sensors and actuators. And it means that this logic must be implemented locally. It is called fog computing in many architectures. And in meteorology, as we know, fog is just a cloud which is close to the ground. So this is a reference model. And we distinguish four major groups of that reference model. So the first one, people and things, you already seen at the previous slide, and it includes act, sense, and operate. The edge and communication is everything about communication from sensors to the cloud. And data actually is nowadays a well-known domain. So everything that is applicable in big data, such as ingestion, processing, storing of data can be taken from big data world to IoT. And application and services, so probably this one is the major, I would say, contributor to business value of IoT system. So we distinguish augmentation of intelligence. So actually, when IoT system helps a human to make a decision using different analytics or reports, and augmentation of behavior when the IoT system talks to application and services directly. And manage and control. Last but not least, often overlooked by architects and designers, this component provides management, provides control, provides security, configuration, and this is actually a nervous system of the modern IoT systems. So actually, this is a foundation of IoT system to manage a massive distributed components. All right?
Yeah. So I'll pick up here. Let me go back. So I would like also to emphasize this thing on the top, like this people things, agent communication, data, application and services. Actually, this is almost the same loop we've seen in the very beginning with this cognitive loop. So actually, this is kind of a loop, just like adding. So this is the implementation view of our reference architecture.
Can you just turn this microphone?
Oh, yeah. Well, I need to turn it on. It's not really smart. So this is the implementation view of our reference architecture, and I would really like to spend several hours maybe talking about it, but I believe I don't have such a possibility. So I will just touch maybe parts of it. So as you can see, these groups, they actually they map some specific system components to the zones and functional regions Serhiy just described. Let's talk, let's say, about agent communication, because as for me, this is this kind of secret glue which actually brings the internet to things. And I'll start with the local and maybe personal networks, which allow you to link devices together and link together and bring the value from local links. So first of all, these are different kinds of wireless sensor networks, wired buses, Ethernet, and even sometimes even extravagant types of communication. Let's say there is a solution which provides an SDK and services to enable audio communication between your devices. So devices like chirp. I can just imagine like my sensors, like crickets chirping on a field, or drones flying and singing like birds. So it's also makes sense for some specific cases. The next thing is actually bridging. So there are hundreds of protocols on application link layer and like network layer. They are not like really small amount of them is really compatible with internet protocols. So anyway, we need to bridge them. We need to make some local computations, transformation, maybe store some data locally, maybe even perform some analytics like this fog analytics. And of course, these devices link us to the big thing, to the internet, to interconnect. And like for interconnect, we see the like traditional base, like cellular, satellite, fiber, and copper connections. But last few years, I'm really glad to see things like LPWAN, so these low power wide area networks. And there are already several standards, I would say, like LoRa or LTE-MTC and others. Okay, so let's talk about quality attributes. So what actually drives the architecture and drives the design of the system? And as you can see, that there are two major, most important qualities. These are security and maintainability. Security, because devices are getting closer and closer to us, to our homes, into our private lives, and they have more and more responsibility controlling things. And maintainability, because, as you know, it's stupid not to think about maintainability if predicted amount of devices is like 20 billions or 50 billions in 10 years. So let's talk about security a bit more, but first I would like to show you some video.
Listen.
For 2 years, Mark Gilbert and his wife have come to rely on their internet cameras.
You almost couldn't live without it.
With them, they could watch their 2 toddlers in their rooms, but over the weekend, someone else was watching too.
It felt like somebody broke into our house.
Gilbert says he first heard a voice from down the hall. As he and his wife got closer, what it was saying got worse.
He said, wake up, Allison, you little.
Soon he knew it was coming from the camera.
I see that camera move on us.
Gilbert immediately pulled the plug and started doing research. He believes that someone hacked his router as well as the camera. The person could see Allison's name on her wall to call her by it. He now wants to warn other parents about the danger.
As a father, you know, I'm supposed to protect her against people like this. And so it's a little embarrassing, you know, to say the least, but it's not going to happen again.
So really scary story. So, there was a lot of studies about this, especially about the baby monitors. So if we look into the study results, what we can see that the vulnerabilities which were detected, they're really trivial to avoid. So this is something. There is nothing special. Somebody forgot to remove service account with default password like admin. Some software architect decided that cloud and local communication is okay with plain text. Some other guys just forgot that device can be stolen, and maybe it's a good idea to encrypt the file storage. So as a part of our reference model, we have this tactics catalog. So I'll talk right now only about security in people and things zone, but actually it covers all the other regions and quality attributes. So as you can see, for security, I would say the most important tactic is the appropriate hardware, appropriate root of trust. Ideally, it should be on a hardware level, like trusted platform modules or maybe trusted execution environments. Also, things like encryption, things like authentication, when you not only authenticate the services, network, but also authenticate your peripherals. So I would like to show you the case study. That's the real project we built last year. This is a smart fridges solution, so it allows retailers to manage and monitor their equipment. So it actually allows them to optimize operational expenses. It also helps marketing and merchandising teams to better place their products. So at this solution, there was a requirement to scale to hundreds of thousands of devices, like fridges. We went with a proven Lambda architecture for data processing for the data zone. So as you can see, there is batch and speed layer. And speed layer actually serves and provides data for interactive journals and dashboards. And batch layer helps with reporting and data analytics. On the things and agent communication side, we have implemented our own hardware, which is optimized actually for durability and for harsh conditions, harsh environments. And the gateways, the bridges, they were built on ARM8 platform. And actually the sensors, we used the ARM Cortex-M platform to build the sensors. And the internal communication was made using I2C and I2C and also radio frequency. And external, the interconnect function was implemented using the GSM. Here you can see the analytics dashboard for this system. So actually, I'll just tell you what it was here. So it shows different repairs, plant repairs. It shows relocations of fridges, violations of different policies. So it's actually a near real time, so the latency is like around 10 seconds. Serge?
Yep. And now it's time for our demo, democratic demo. And by the way, this is nowadays is mind-shifting trend in IoT, democratization of devices. So it means that device, instead of just a passive object, acts as a active subject. Device can pay for services, or device can provide own services.
Make decisions.
Have a wallet, and so on. So in this demo, we will demonstrate just a simple business idea of automating feedbacks. So you all seen these feedback forms, like voting forms, paper voting forms, right? So it's boring, right, to fill them, and we all know that it's difficult to remember what was yesterday. It's always difficult to rate it properly, and so on and so on. So why not to help organizers and measure a sound of applauses, for example, right? And this is automatic, this is real time, and you can do it in every room. So this demo is, let's demonstrate it.
So here in the room, we have 4 wireless sensors. So actually, they measure the sound levels, and they feed this data into the internet in a safe and secure way. Believe me, this is not like recording devices. They're just measuring levels. So how this thing works? Let me start it first, because this thing needs some time to process the payment. I'm here. I'm a user, and I want to buy sound level sensors, like talking with a gateway. So let's imagine here is our room, the conference room 404. There are some environments, some like equipment here, like whiteboards, projector, sound mesh, and we want sound mesh. And there is a price. It's like 5 cents of a ZRAM per minute, and ZRAM is a crypto coin. It's not bad, like it's not really expensive, so I'll buy it 30 minutes. I see like, yes, 30 minutes, yes, I know, 1.5 Ether, I'm good. This is the, like, this is the my wallet, my crypto coin wallet. This is the crypto coin wallet of devices. So I pay directly to devices. Payment succeeded. Now we should see a dashboard. The transaction itself will take several seconds, because the blockchain we bring up, it's really small. It contains just several nodes. So in a blockchain with thousands of devices, it will be really quick. So as for now, let's go back to our presentation. Who heard about blockchains? Like, oh, not bad. I heard of them like just yesterday. Okay, so the idea is that all the guys here, either this is a systems, devices, or whatever, they are all businesses. So when I am as a user, pay to blockchain contract, and this is a piece of code which is executed inside distributed virtual machine. So this virtual machine, it's executing the code on all the devices which participate in this blockchain. So blockchain contract pays the money for dashboard services. It also pays sensor gateway for the data for this 30 minutes. It probably pays a few cents to his owner, just he's not hungry. And actually, sensors and devices itself, they are fully, I would say, they have full rights in this system, in this philosophy. They can pay for electricity, they can pay for hardware, They can search on some specific sites, let's say on IPFS, it's Interplanetary File System. I don't know if you heard about it, but there is things like this. They have found a rating for some like tech support, and if the rating is good, they can pay these guys like their own money. And of course, pay sensor's owner. But the owner is a temporary guy because usually devices like their lives are longer than even the companies which own these devices. I believe there are a lot of devices in the world with no owner at all. So let's go back to our dashboard. So you can see only 3. I believe one device either died or something like this. Yeah. So you can see the signals, right? Let's play some.
Yeah, let's play some simple game just to test this this system. Applauses from this
side.
From this side.
Yeah,
Let's do it.
Whoa. Okay.
All right.
Then this side.
And you guys?
Okay, so I have Kibana here. It gives me a better picture. So I would say that Sensor 3 is a winner.
Sensor 3.
Yeah,
Who is Sensor 3?
Sensor 3 is over there. Like it's
Yay!
great. So
anyway, I think that everyone did a great job. So and we have Tex and Candice. So Andrei,
authentic
please
Tex
redistribute.
and Candice. Yeah, just pass it. So,
yeah, and just a quick summary, and if we have time, we'll address several questions. So back to the nature, IoT systems resemble human as an organism, and human society, actually, the democratization of IT devices represents this a new mind-shifting trend in IoT. The SCI architectural methods, they are well applicable in IoT domain too. So quality attributes and tactics, they help design and evaluate complex IoT solutions. And security is a significant challenge, as we've seen in this short video. But most vendors already have started realizing it, and we'll see this change, we hope, in the near future. Thank you. And questions?
Yes, thank you. So, we have some time for questions. If anyone has anything, if you have finished eating your whatever it was. Questions? Okay, I have one. So, how do you protect your devices, your wallets, and your stuff in this scenario?
So actually, the device itself, like this, the devices. This is not just like the device you have. You have a wallet here. You can open it and take the money. No. So there is separate software. I would say architecture pattern family for so-called smart contracts. So it's not really similar to all the patterns we know. So there are like system, and one of these patterns is manager of these devices. So actually there is a virtual manager which executes inside the blockchain and actually manages money, gets payments, like make all this stuff. So locally on devices there is no wallets.
Okay. Yes, another question? Yes, you need the microphone for the cameras to work.
Hi, thank you. So you mentioned that the two most prevalent quality attributes you saw were security and maintainability. What are the trade-offs that you see between those? Because you didn't actually mention that in your discussion. And how do you deal with those?
You mean between those, or? Like
sure. Between if your whatever you do for security and whatever you do for maintainability, are they in a state of mutual tension?
I don't like, especially in the people and things zone. I don't think they are in some conflict, because both the maintainability and security is being achieved by some computing power and actually by some power, by some energy. So usually you will have a trade-off between how much money you can spend for some hardware versus should I have software updates, or can I afford a TPM like chip on a device? So if you get more computing power, if you get some additional access to some energy, you can achieve both security easier and maintainability in the same.
And probably we need to expand a little bit that maintainability.
Maintainability.
Yeah, it includes upgrades, so upgradeability, for example, and this is also one of the challenges in IoT. If that system serves millions of devices, that for sure is a key feature that needs to be implemented there, right?
Yeah, and actually the maintainability part, especially for devices, is a pain because probably you all know these DevOps and configuration management frameworks like Chef, Salt, Puppet, whatever. There is nothing like this for devices which are not able to run Linux. And actually, there is a good work on getting these standards. For example, the Open Mobile Alliance has this LWMTM standard, which allows you to manage the firmware, manage configuration, manage other things. But anyway, you need to implement it on your own. So this is kind of hard part, and everybody does it on their own. But I hope at least everybody will follow some standards like LWMTM.
Okay, and there is another question here.
So, guys, I have the following question. You actually gave wallets to your devices. These devices will start order pizza and deliver from Amazon. And finally, the question is, do you realize that you are building the reality that was described in Terminator movie? So please pay more attention to security.
Security was on the first place, so security and control.
Okay, another question.
Yeah, about security. You mentioned the fact that you rely in the architecture that you've shown on the trusted protection modules and on the hardware root of trust. Do you have a strategy, an idea, options when you actually do not control that piece? So what about the case in which you deploy software on items that do not possess those kind of capabilities?
Because,
for example, the TPM is not there, or is not supported, or it's a legacy device and doesn't have that kind of capabilities in there.
So I'll try my best to achieve the maximum level of security using the firmware root of trust, or just use the architecture of the chip, because especially these modern Cortex chips, they have this protected environment where I can execute the code. Yeah. Cortex, yeah, right. And actually, TPMs are pretty expensive, but recently STM, they manufactured a new model. It has almost the same features which TPM has, and like the level of protection, but it's like way cheaper, like 10 times, etc. So it's really usable.
So you showed us some IoT-specific security tactics, and I just wanted to see if you developed them on your own in-house, or are those borrowed from somewhere else?
Okay, so as a preparation for this conference, we've studied a lot of different materials, and actually we've started the IoT thing at SoftServe a year or even more ago. We have a lot of embedded system development legacy. So this is not something new for us. We analyzed a lot of other reference architectures from Industrial Internet Association, from IoTA, from Deloitte, from like a lot of different stuff. And actually we choose our own way. And the part with the tactics, it's not a copy-paste. It's like based on our experience is embedded with devices, with clouds, with everything.
Yeah. So you may see some tactics in other reference architectures, but this compilation actually helps us to keep it in one place and to be useful for designers.
Okay. Any last question? Yes, sir.
I'm not sure if I have seen in your architecture, maybe it is there, but if you are considering this type of democratic devices, exchanging the data, which means you need to have also a broker who maybe are just dealing with this data, who is offering better price, or some load balancing, and I'm not sure if I have seen in your architecture, it was too quick, your slides.
Yeah, so the architecture we presented, in the first version, it had a blockchain. We just moved the blockchain just more to fun part, because right now blockchains, they are not really useful. Like there is a lot of stuff to be implemented around to make them useful. Let's say even in decentralized system, like the blockchains are, where there is no root, there is no control center. Anyway, there are some services which are needed. Let's say exchanges, side chains, I don't know, registries to find these services, like the standards to how to define a contract. So my stupid device can understand, is it this contract okay or not? So all these things, I believe they will appear. Right now, IBM actually and Samsung are moving in that direction and spending a lot of money on it. And they already built a reference architecture for this thing, which includes hierarchy of blockchains on starting from the worldwide registry, down to the organizational level.
Okay. Thank you once again. Next up in the program are two lightning talks that will be in the main hall. So you have a few minutes if you want to catch them.